This is DammySWOT once again. Here in this video, we want to give solutions. I'll be giving solutions to literally all the questions on this exercise 2.6 of vectors of page 30 in this textbook. So I want you to first of all ensure that you like all the videos on vectors and this video in particular, and as well subscribe. Very important you do that, and at the same time you share and comment. Now when you do all this, it gives more opportunity to do more, and gives the spirit to do more. And at the same time, when you share to others, it makes the video go viral and more comments. And by doing that and by commenting, we get to have more questions on my DM. So if you check the description of every videos, there is always a link to my WhatsApp contact, so you can easily DM if you have further questions. So without wasting much time, so let's go into the questions. Here will be I hope we can solve everything. I hope we can finish everything in one video, so I'll just try to cut all the videos so that it won't be too lengthy. So let's just go straight to the question 1. Now for question 1, first of all, you need to understand some things in solving questions. Let's interpret the question first of all. It says a vector undergoes 3 successive displacements in a plane as follows: 4 meters southwest, 5 meters east, and 6 meters to the direction of 6 meters to the direction of 60 degrees north of east. So this is literally giving us to a cardinal points, leading us to 4 cardinal points. So in these 4 cardinal points, we have the east, we have the west, we have the north, and we have the south. Okay, so let's interpret our questions. So first of all, we have 4 meters southwest. So 4 meters southwest. Okay, no direction. Let's take note of that. Southwest, meaning south to west. South to west. No direction. No direction. It's just giving us the magnitude of the movement of the particle, 4 meters. So okay, then we have 5 meters east. Okay, 5 meters east. On this straight line, we have 5 meters, no direction. For 5 meters, it's just equal to 0, so you can understand. So the angle for this one is equal to 0. But for this one, we don't know, but partly it's being shared equally between west and south. So here we'll be having, let's say, 45. Yes, 45 degrees. Then and 6 meters in a direction 60 degrees. Okay, northeast. Let's just take this one as from here to here 60 degrees. Then the direction of the movement of this particle across this place is 6 meters. Now one thing you should understand that is that first vectors, the angle moves in anti-clockwise direction. Anti-clockwise direction should first follow. So meaning that the movement of the particles is like this, is in this form. It's in anti-clockwise direction. So for this one to move this way, this is not the right angle we are making use of. The right angle we'll be making use of is from here to here. That will be the right angle we are making use of. So we've not gotten to that aspect, but for now we have this displacement. Yes, each of them have their specific direction of angle. So that's one thing you need to take note of. So the question then says find the magnitude of the direction and also find the magnitude of the resultant displacement. Okay, so before we find the resultant, before we find for direction, we need to first of all find for direction, we need to first of all find for the resultant displacement. So the magnitude of the resultant displacement, and from the previous videos we've made, I've explained and shed more light on what they want to talk about resultant displacement. For us to find, or when we are resolving vectors, we need to understand that resolution of vectors has a formula. Magnitude of resultant displacement is literally square root of the x component plus squared plus the y component squared. So now this, okay, looking at this now, with the knowledge of component, this is literally our x-axis. So we say this is the x component, then this is the y-axis, and this is our y component. So we want to resolve this first with knowledge of x component and y component before we can get our resultant displacement. Now all this specific particle is moving in this component, is also moving in this other component. So first of all, we need to get the sum of all the displacement for these particles. So this particle is moving, okay, let's just assume our magnitude, our vector is vector A. So let's also assume it's vector A. So for a particle moving in x component, we say a x component has a specific formula, which is from our previous video you can get that, but straight to the formula, it is a, or the magnitude cos theta. Now don't forget, these particles are three, the movement of this displacement are in three forms. So let's just denote all these displacements with I, J and K. You know what I mean by I, J and K? The direction of the displacement. So this is I, then we are taking the sum of everything. So this is J, same way, plus K, the same way, cos theta. Very good. So now this resolution for x component has a specific formula, which is a, or x component, let me just say x component equals to a cos theta. It could be b, it could be depending on the vector, it could be depending on the magnitude of the vector. So this is the formula. First formula you should first of all take note of. This is another formula you should also not forget in vector. So straightforward, let's go ahead. Then what is our AI? When it's talking about I is talking about in this direction, x-axis. Let's talk about this as our J, and let's make this our K. Are we together? Let's make this our J, and let's make this our K, because this one is actually moving in the negative direction. So let's make it our J. So for this now, let's start. I is 5. The magnitude of I is 5. Then cos, what's the theta? This 5 is moving in no direction, so that's 0 degrees, plus, then AJ is 4. The magnitude of J is 4. Then what cos? This theta now, you know, we don't take the direction in clockwise direction, we take it in anti-clockwise direction. So from here to here is 90. From here to here is another 90. Then from here to here is 45. So we'll be having 90 plus 90 plus 45. That's 225 degrees. So this will be 225 degrees. Yes, take direction in anti-clockwise direction for, we take our angle in anti-clockwise direction for vectors. So A, then for the last K, so 6 cos, the direction for this is already given, 60 degrees. Yeah, 60 degrees. So straightforward, let's just make use of our calculators to make it very, very fast. So here we'll be having 5 cos 0 degree, that's 5, plus 4 cos 225 degrees, that's okay, change it, so we have minus 2.83 plus 6 cos 60 degrees, that's 3. So let's add everything together and let's see what we'll get. So let's take a look at this. For our x component will be 5 minus 2.83 plus 3. So we have 5.17. Yeah, we have 5.17. Literally, let's say just 5.2. Okay, well, let's take a look at it. 4 cos 225. 4 cos 225. All right. 4 cos 225. That's minus. Okay, that's 5.17. Yeah, 5.17 meters. This is for our this is for our x component. So let's go to our y component. So our y component is in y comp is a sine theta. Take note of that. Is a sine theta. So here we would still have the same method here, which is ai sine theta plus aj sine theta plus aj sine theta plus ak sine theta. So straightforward, we have 5 sine 0 degrees plus 4 sine 225 degrees plus 6 sine 60 degrees. So straightforward, let's check our answers. 5 sine 0 is 0. 4 sine that's minus 2.83 plus 6 sine 60, that's 5.2. all right, so let's go ahead. So from here we have let's take a look at it. So let's add it together. That'll be 0 minus 2.83 plus 5.2. So we have 2.37, yeah, meters. So we have 2.37 meters. So that is for our y component. So our y component is this, then our x component is this. So that is not done. So when we can now move into the resolving of our components now, so we can get our displacement. The magnitude of resultant displacement is now equals to the square root of our component 5.17 squared plus 2.37 squared. So straight up we have, this is the first formula, this is the second formula you should not forget. This is the second formula you should not forget. Then straightforward, here we'll be having square root of, that will be square root of, let's just take a square of it, that's 5.17 squared plus 2.37 squared. So that's 32.3458. So the square root of this is then square root of your answer. Square root of your answer is 5.68, or let's say 5.69. Yeah, 5.69 meters. So this is our answer for our magnitude of resultant displacement. This is our answer. So that is just literally what you need to understand about resolving resultant displacement. You can resolve a vector, maybe I, J, and K. You can resolve a vector in literally just I. You can resolve a vector in J. You can resolve a vector for K, depending on the displacement or the direction of the displacement. So that's literally what but you are not done, because you just solved for this. So the question says the direction. Now for finding direction, direction is literally talking about the angle. This is direction. Direction. It also means argument. I think we shouldn't forget. It also means argument. So for direction of displacement, direction of displacement, this is 1, then this is 2. Question 2. Direction of displacement is equals to, or is solved as tan theta. This is another formula you shouldn't forget. Tan theta equals to y components over x components. So we are referring to a vector A. So tan theta, we've gotten our y component. What's our y component? Our y component is 2.37 x components. So that's what's our x component? 5.17. So then that is equals to, let's take a division of that. Let's take a division of it. So that's 2.37 divided by 5.17. 3.27 divided by 5.17. So convert it. So we have 0.4584. So tan theta is equals to 0.4584. Now take the tan inverse of this. So tan inverse of 0.4584. How do you get, or how do we press tan inverse in calculator? This is how you do it. How to press tan inverse in calculator? This is what you should do. You just press shift, then tan. You have tan inverse. Shift, then tan. Then you put 0.4584. Close your bracket. Very important. Then you press equals to. So your theta is equals to 24.63 degrees. This is in meters. Don't forget. The magnitude of your resultant displacement is in meters. The magnitude of your directional displacement is in degrees. So these are your answers. So, but take note, you can also be asked, in what direction is this angle moving? This angle is moving in northeast direction, because that is the only angle that was given in your question. That was the only angle that was given in your question, northeast. So we are having it to be resolved in northeast direction. Take note of that. To be resolved in northeast direction. So this is 5.69 meters and 24.63 degree northeast. Simple. That's for question 1. That's for question 1. So for question 2 now, question 2 is also simple. You just need to understand some basics. Now, taking you back to what you need to understand about subscribing. Ensure you subscribe to this channel, like this video, share it to as many of your colleagues and your WhatsApp platforms. Share to all your WhatsApp platforms. Like, share, comment in any aspect. Then if you need to reach out to me, ensure you message me on my WhatsApp link in this description. So straightforward, let's go to the next the next question. It says, given that F1 is 3i plus 4j plus 5k. Take note of that. Then F2 is 2i plus 3k. Whenever you don't have j, take note. When you don't have j, it means your j is 0j. Take note of that. Very, very important. Then F3 is equals to 6i minus 7j minus 8k. Now then I said find 3f1 plus 2f2 plus 3f3. Simply means what you are doing is you are multiplying this by 3 for f1, you are multiplying this by 2, then you are multiplying this f3 by 3. So let's just take a look at the answers. So 3f1, let's take a look. 3f1 is going to be 3 times this, that is 3 to the bracket of 3i plus 4j plus 5k. So what will you have? You'll be having 9i plus 12j plus 15k. What you are doing, you are multiplying, you are expanding the bracket. That's just literally. So we've also talked about addition, subtraction, multiplication of vectors. So under the description button, you also see the multiplication of vectors as well. So this is for 3fi. So let's go to 2f2. That's 2 times our f2, our vector 2, 0j plus 3k. In the question, there is nothing like 0j. But when you have questions like this, it simply means if nothing is given, you denote it as 0j or 0k, whichever one that is not given. So equals to, let's take our multiplication, let's expand. 4i plus 0j plus 6k. That's for our. Then let's go to the f3. 3 times our f3. That is 3 to the bracket of 6i minus 7j minus 8k. That is equals to 3 times this, 18i, times 3 times this, 21j, 3 times this, minus 24k. So now the question now says find the summation of everything. Now this is leading you to addition of vectors. When you are adding vectors together, you add all the directions together, or you add all the displacement together. Now for this, we'll be adding everything here together. We'll be adding everything here together, inclusive with the sign. You'll be adding everything here together. That is when we have addition of these three. So to add everything together, we have 3f1 plus 2f2 plus 3f3. So meaning that to add these three vectors together, this plus this plus this, that's 9 plus 4 plus 18. Let's quickly use our calculator. Though we have a calculator method to this, but to save our time here, let's just use our calculator here. That's 31i. Then let's take a look at this. Plus 12 plus 0 minus 21 minus 9j. Then finally 15 plus 6 minus 24. That's minus 3k. Good. So this is our final answer to this question. That's for question 2. It's just as simple as that. Don't forget to subscribe to this YouTube channel, share this video at the same time, comment, and endeavor to tell all your friends and colleagues to also subscribe to this channel. Like, share, repost as many times as you can. So in the next video, I will be talking about the question 3 and question 4. So turn on your notification button so that when I solve that, you get notified of the answer to or solution to question 3 and question 4. So I'll split it into two to make it fast. Thank you very much.